Welcome to another online video. We are going to be talking about pyramids today and talking about surface area as well as how to draw the net of these kinds of shapes. It's lesson 10.5. Make sure you have your notes. For my table of contents, I actually am on page 100 today for these notes, so fill in that and we'll get started. So let's talk about a pyramid and what properties it has first. A pyramid has at least 3 triangles that meet at a common point or a common vertex and have some sort of polygon as a base. I have some examples here to show you. This one is the most standard. You see these in Egypt. This is a square-based pyramid. Notice these are triangles meeting at a common point, and you have a polygon that's a square for a base. Another one that we're going to talk about a lot is the triangle-based pyramid. So all of the sides, no matter what, is a triangle. So you have a base that's a triangle as well as all of the faces. Just for fun, you do have, this is a pentagon base, and you have the triangles coming up, and that's kind of a cool one. And we also have the hexagon base, and then you have the triangles coming up to a common point. So those are some examples. You can see the square-based pyramid, the triangle-based pyramid, and then one that I don't have in actual 3D form is called a rectangular base pyramid. So same idea, you just have a rectangle on the bottom instead of a square. Now that you've seen some of them, let's go through the actual parts of it and label those lines. Each triangle face, we're going to call it a lateral face. So that's this part right here. We have 4 lateral faces on the square-based pyramid, and this line is pointing to the bottom, meaning the base. So that's another part of the pyramid you need to be familiar with. The point where they all meet, there's actually 2 different names for it. We're going to put the vertex, that's the common point where they all meet. It's also called the apex. Notice it kind of ends the same. It's just that common point at the top. And last but not least, if you notice on the square-based pyramid and all of them, the lateral faces are slanted so that they all can meet at that common point. So the distance from the bottom of that side all the way up to the apex or vertex is going to be called a slant height. So you'll see that this right angle symbol is here, and then it's a dotted line. You're going to see that a lot throughout the next couple of days. This is called the slant height. Again, it has that H, it's dotted line, dashed line, and you're going to see the same kinds of things when we actually break this down. When we break a pyramid down into its net or orthogonal drawing, we're going to see different ones here than I'm going to display behind me. For the square-based pyramid, I like to think of it as a flower because you're going to take each triangle and bend it down with the base in the middle. That's how I like to draw them. Now this one actually looks a little bit different than that. They did not choose to take each triangle and peel it back, kind of like a banana. Instead, they chose to keep the triangles together and just have the base kind of hanging off of one of the bases of this triangle. So this is another way to show a net, but I like to use the flower kind of looking net instead, and we'll just label those same pieces. The center is still the base. These triangles around the base are the lateral faces. And then this dotted line, you can see it in each lateral face. Those represent how tall the triangle is or the slant height. So those are the vocabulary words we're going to be using when we're talking about pyramids. Now, because we're just focusing on 3 kinds of pyramids, square-based, triangle-based, and rectangle-based, I'm going to show you those nets so that you get an idea of what we're going to be drawing and creating. The one you just labeled on your notes is an example of the square-based pyramid and a net of it. These 3 that are underneath on your notes are the other types. So you have two examples of a triangle-based pyramid. This one in particular is a special one because this is when the triangle in the center, the base, is equilateral. When that's the case, you can go ahead and put those hash marks around it. That means the three petals or triangle lateral faces that are around that base are all going to be exactly the same size. So you can put hash marks on every line segment that you see, or the middle one. So that's when the triangle is the same. When it's not, over here we have an isosceles triangle. The petals or the triangles coming off of the three sides of that base are not going to be the same. So you're going to have to find the base, and then you're going to have to find the area of the triangle lateral faces. The last one is when the pyramid has a rectangle base. These are going to have opposite triangles having the same area. Opposite sides of the rectangle will be the same. So that means that this top triangle and the bottom triangle are going to be the same area because of the line segment being the same on either end of the rectangle. So those are just some pictures to get us familiar with what we're going to be creating when we draw a net. So let's talk surface area. It's going to be the same process that we've used for rectangular prisms, the same process that we've used for triangular prisms. You're going to chart all of the faces and find the area. Once you're done with that, you're going to combine what you need. So the only thing that is a little bit different with pyramids is that sometimes you're not going to double everything. Like you saw with the triangular prisms, we had two triangles and then three different types possibly of the rectangles. So you have to look at what kind of shape you have and determine, do I double it? Do I not? Is this the only area like this, or can I double or quadruple it? So the chart's going to look a little bit different, but the basic idea is the same. There are two specific formulas that we will practice as we go along, and it has to do with when a triangle-based pyramid has all equal sides. If that's the case, you're going to have 4 identical triangles. So you only have to find the area of one triangle and then multiply it by 4, instead of finding them all separately and then adding up 4 numbers. The same kind of thing we can apply for a square-based pyramid. The square-based pyramid, you're going to find the area of the square, which is the side times the side, or the base length times the base length. That's the b squared. And then you have 4 identical triangles, 1, 2, 3, 4. So you can find one triangle, half base times height, and then just multiply that number by 4, and you have your area when you hug all of the surfaces. So on the inside, we're going to do some examples, 2 visual and 2 word problems. So we have a square-based pyramid here, and we know the base of the pyramid is 7, and the slant height is 9. So if I were going to chart it out, I would still need my face column and my area column. I'm going to work with the base first. That's going to be 7 times 7, which is 49. I can't do anything. I don't want to double it because there's only one base. So that's this part right here. Now I'm going to look at the lateral base. That is this triangle right here. I want the distance or the slant height, which is 9. That's going to be the slant height. And then this is our base. So when we plug in our area formula, 1/2 base, which is 7, times the 9, we can come up with the area of one of the lateral faces. 7 times 9, 63. Half of that is going to be 31 and a half. Now remember, that's just one. And now let's think, how many lateral faces do we have? We have 1, 2, 3, and 4 of them. So now I can multiply this by 4 and get all of the lateral faces right away. When I multiply that, I get 126. So for this one, when I'm finding my surface area, I only have to add up 2 numbers. When I do, I get 175. I'm dealing with centimeters. I'm dealing with area. So that gives me 175 centimeters squared. because this is a square base pyramid, I'm also going to show you that formula that was on the front. It ends up being the same process. Here's just with symbols. This is the area of the triangle lateral face. There's 4 of them, and then we have to add the base length that's squared. So now let's pluck and plop. Our 7 is our base. So we're going to put our 7 again in here, and then our 9. You'll notice it's the same math, 31 and a half. That's then being multiplied by 4. When we take 7 squared, same thing as 7 times 7. And you can see we get the same exact answer we got here, 175 centimeters squared. Before we move on to the next one, I want you to find some space. Hopefully you didn't use it all, and I'm actually going to draw this net. So I find these a little bit easier than the nets we've been drawing previously. We're starting with that square, which is 7 by 7, and then we're going to put, to the best of our ability, you might want to use a straight edge, 4 triangles coming off of each edge of that square, and the only thing you have to add is this dotted line, and that dotted line represents the 9 centimeters, and I'm just going to stick the unit here. And that's all it is when you're drawing a net, a square base with 4 triangles around it. Forgot to do that before we solved, so I did it after. Here we have a triangle base pyramid. I'm going to do the net first this time. This picture, looking at the 3-dimensional one, is a little bit more confusing than the square base pyramid because you have 2 dotted lines. You have 2 heights. So we're dealing with the base of the shape's height and the lateral faces height. First thing I'm going to do is shade this base. This dotted line going to the right has 3.5. This is the base's height. So when I'm drawing my triangle that represents the base, this is going to be 3.5, and my sides are all 4. I know it doesn't look the same because they're, again, drawing it on a 2-dimensional piece of paper, but all sides of this triangle are 4. Now I can take a look at my lateral faces, which are also triangles, using a different color here to see it, and this height represents the slant height. So when I draw my triangles coming off of each part of the base, they're going to be 5 feet tall. Obviously this is not drawn to scale, and then one will come off in this direction. So each one of these will have a slant height of 5, and I know this one has that 3.5, but it will have the same slant height. That's the net. Now let's chart it out. We can't do any formulas, so the chart's the only thing we're going to do to solve the area. The chart's the only thing we're going to use to help us solve what the surface area is. So we have our base and then our area. I'm going to work with the base first. I'll label it the base, and I'm going to use the area formula for a triangle, 1/2 times the base, which is 4, times the height, which is that 3.5. Half of 4 is 2. 2 times 3.5 is 7. Now let's deal with those lateral faces. I'm literally going to write lateral face because that's the piece of the pyramid I'm looking at next. So the lateral face is also a triangle. It has a base of 4, but now it has a height of 5. Half of 20 is 10. One of my lateral faces is going to be 10. Now, how many of those triangles do I have? I have 3 of them. So really, I need to multiply this 10 by 3, and the 30 is what I need to use to add up all my sides. Like always, we are going to see word problems as well. So here's a trophy in the shape of a rectangular pyramid with a base measuring 3 inches long and 2 inches wide. The slant height is 2 inches high. That means all around it's 2 inches high. What is the surface area? So let's start by drawing a net. So it has a base of a rectangle. This is 3 inches and this is 2 inches. And then we're going to have to go up 2 inches coming off of each rectangle side. So notice I did my dotted lines first, 2 inches that way, north, south, east, and west. So we're going to then use a straight edge to connect the height with the edges forming those triangles. So that's a good strategy when you are making your triangles. Go up from the middle, the distance of the slant height, and then connect this point with the other points making that triangle. So here's our net. Now we're going to use a chart to find the surface area. We have our face, and then we have our areas that we're finding. I'm going to deal with the base first. The base is a rectangle that's 3 by 2. We just have to take the length and the width and multiply them together. There's only one base, so that's the number we need when we're adding everything up. Now this one, we have the longer side of the rectangle has 2 triangles coming off of it that are exactly the same. So let's deal with that first. We're going to do the lateral face that in our net is on the top and bottom. So top and bottom lateral face is how I'm going to refer to it because of what I'm seeing in my net. And that's going to be 1/2 times 3 times 2. This is 6, half of that is 3. But remember, there are 2 of them. So I can double this and get both my purple triangles right away. I'm going to shade these little guys over on the left and right. These red triangles are also going to be the same area. So I'm going to call those the left and right lateral face. And that's going to be 1/2 times 2 times 2. Half of 4 is 2, but remember, there are 2 red triangles to the left and right, so that means I need a 4 when I'm adding everything up. For this surface area, I'm going to add up the 6, and the 4, giving us an area of 16 inches squared for the surface area of that trophy. I want you to try the second word problem on your own, and then I'll come back and show you what I did to solve. And then remember, I want you to draw the net. You can chart it out or try a formula. So hopefully this one wasn't too bad for you. I wanted you to draw the net. You have the equilateral triangle in the center, and then the 3 petals or lateral faces coming off of that base are all going to be the same size. So I put hash marks and labeled the 8, and I also needed to include the slant height of 6.9. My chart isn't a very long chart because the base is what I started with, 1/2 times 8 times 6.9. But then because this area is the same as the lateral faces, I just needed to multiply it by 4 to get my answer of 110.4 centimeters squared. My surface area formula in this case can work as well. You don't have to chart it out. You can just pluck and plop into this formula. You can see that the math ends up being exactly the same as what we were doing with our chart. Either way, you should have hopefully gotten 110 4/10 centimeters squared. We're going to work with pyramids. It's the last skill in Chapter 10, so I look forward to seeing you tomorrow. Enjoy the rest of your day. Bye.